An N-channel JFET has IDSS equals to 10 milliamps and VP equals to -4 volts. Determine the minimum value of VDS for which the pinch-off region VGS equals to -2 volts. That is VDS min is. Here VDS for the pinch-off region should be VGS minus VP. So VDS min is equals to VGS minus 2 plus 4, which is equals to 2 volts. That is option A is correct. Open circuit works as. Here if we apply a KCL at node A, I1 plus IF equals to 0. Here V0 is nothing but IF minus IF into RF. So here IF is equals to minus I1, that is I1 into RF. So I1 is decided by IS. Hence input parameter is current and output parameter is voltage. Hence it is nothing but current to voltage converter, that is option B is correct. Resistance of a non-inverting op amp is. Here R in is nothing but this. So R in is equals to V1 by I1. Here this node potential is V1, so this. So if we apply a KCL here, that is I1 is equals to V1 minus V0 by R. This is equation 1. Similarly, if we apply at this node potential V1 by R1 plus V1 minus V0 by RF. So here we have to eliminate the V0 variable in the equation 1 in order to get an equation only in terms of V1 and I1. So V1 R1 RF divided by R1 plus RF, this is RF, equals to V0. So V0 is equals to V1 R1 plus RF by R1. I1 is equals to, we have to substitute this into equation 1. So V1 by R minus 1 by R. V0 is, this is V1 R1 plus RF by R1. So I1 by V1 1 by R minus 1 by R 1 plus RF by R1, that is RF by R1 into R. So R input resistance is V1 by I1, so R1R divided by RF. So option B is correct. Square wave of time period 80 microseconds can be obtained from a square wave of time period 10 microseconds by using. Here we know that in case of a mod n counter, F in F out, which is equals to F in by n. So T out is equals to n T in. So here T in is 10 microseconds, T out is 80 microseconds. So n is equals to 8. This is number of states present in a counter. So if we take option A, that is 3-bit parallel counter, there are 3 bits means 8 states are possible. In case of B, 16 states are possible. In case of C, 16 states are possible, and in case of D 2 power 8 256 states are possible. So option A is the only option correct. User states in 3-bit Johnson counter is here. If in case of an n-bit Johnson counter, there are 2 power n states, that is 2n states, but the number of states possible are 2 power n. So the number of unused states is nothing but 2 power n minus 2n is equals to unused states. So here n equals to 3, that is 2 power 3 minus 6, that is 2 states are the unused states, that is option B is correct. 8085 microprocessor, which one is the longest instruction among the given following? Here, out of 74 instructions in 8085, call instruction is the longest duration instruction, which takes 18 T states, 5 machine cycles. So option A is correct. Of e power j omega is a high pass filter, then h of e power j of omega plus pi is a. Here, if we draw this one, minus pi to pi, this is the digital frequency, this is the high pass filter representation, this is cutoff frequency minus omega c. Suppose this is h of e power j omega. H of e power j omega plus pi means you are shifting to the left by pi, that is you are going to get this one. So it acts as a low pass filter, that is option A is correct.
These are used to construct a 3-phase 3-pulse cycloconverter. Okay, for 3-phase 3-pulse cycloconverter we will use 18 switches, whereas for 3-phase 6-pulse converter we will use 36 thyristors. So option C is the correct answer.
Response of an LTI system to a unit step signal is 3 by 2 of 1 minus e power minus 2t. Then the impulse response of the system is, we know that del of t and u of t related in time domain as du of t by dt. So LTI system is nothing but input and output are linearly related. So if the input is really differentiated, then the output is also be differentiated. So if this is an LTI system, u of t we are getting 3 by 2 1 minus e power minus 2t. But to the same system, if we give del of t, which is equals to the differentiation of u of t, so the output must also be differentiated, that is 3 by 2 1 minus e power minus 2t, which is equals to 3 e power minus 2t, that is option B is correct. Crossover frequency of